Dear students, welcome back. Welcome to Mathematics Online classes. Today we will solve the problem number 25 in the exercise 9.3. This exercise is 9.3. Up to problem number 24 it is already completed in the previous session. Now 25. It's saying A, B, C and D are in GP. Means A, B, C and D are in a geometric progression. Then we need to show A square plus B square plus C square into B square plus C square plus D square is equal to AB plus BC plus CD whole square. They have given you, it is given that A, B, C and D are in GP or in geometric progression. So what I will do, I will choose this one. Let A is equal to A, that is the first term of the GP, and B is equal to second term of the GP. I will choose that B is equal to AR, and C is third term of the GP. I will choose this one as AR square, and D is fourth term. I will take this one as A into R because it is in geometric progression. Fine. Now you take the LHS which we need to prove here. LHS is A square plus B square plus C square, which is multiplied with B square plus C square plus D square. Substitute all these. A means I have taken A only, put it as it is, A square, plus B in the sense we have taken AR, A into R whole square, plus of C means AR square. AR square is C, this whole square will be there. Complete this bracket. And now coming to the second one, B square means A into R whole square plus C is A into R square whole square will be there, plus D is A into R cube and whole square will be there. A square plus A into R whole square is nothing but A square into R square. Write it. A square into R square plus this one is AR square whole square is nothing but A square into R square to the power 2 means that is nothing but A into R raised to 4. Here I am using the formula, means laws of indices. A raised to M whole raised to N is equal to A raised to M into N. And here A into R whole square means it is of the form A into B whole square is there. If suppose I have A into B whole square, not only square, we can have any power here. A into B whole to the power of M can be written as A to the power M into B to the power M. Those two laws of indices I am using here. Okay, this first bracket completed. Now coming to the second one, it follows the same thing again. First laws of indices, A into B whole to the power M equal to A raised to M into B raised to M. This is A square into R square plus A into R square whole raised to whole to the power 2. A is A square. See, R square to the power 2 means A raised to M whole raised to M. That is nothing but A raised to M into N. So here I have R to the power 4 plus of next thing A square R to the power of 3 into 2. That is nothing but 6. Okay. You take the common terms from both. From first three terms you observe A square is common. Take it out. A square into what are the remaining? 1 plus R square plus R raised to 4 is common. Sorry, R raised to 4 remains there. From these three terms, what is common? A square into R square I can take common. A square into R square. A square into R square is already outside. 1. A square is outside. R 2 times already outside. 2 times it will be here. R raised to 4 ಅಂತ ಹೇಳಿದ್ರಿ. ಎರಡು ಸರಿ ನಾವು ಹೊರಗೆ ತಗೊಂಡಿದ್ದೀವಿ, ಇನ್ನ ಎರಡು ಸರಿ ಅಲ್ಲೇ ಉಳಿತೈತಿ. Plus of A square is outside. R 2 times we have taken, 4 times it will be there in the bracket. You see, A square into A square, I can write A square whole square into R square. 1 plus R square plus R raised to 4. 1 plus R square plus R raised to 4 can be written as 1 plus R square plus R raised to 4 whole square I can write. Fine. See, these two terms, A square is there, R square is there. Means if I use this formula reverse, this can be written as A square into R whole square. as it is like a raised to m into b raised to m. I am writing it as a into b whole raised to m. A square into r whole square, which is multiplied with 1 plus r square plus r raised to 4 whole square. Now you observe these two terms again are like a raised to m into b raised to m. A raised to m into b raised to m. Both the powers are same here. If I take this one as a, this as b, I am writing in the form a into b whole raised to m. That is nothing but a square into r, which is multiplied with 1 plus r square plus r raised to 4. This is second term b. This is first term a whole raised to 2. This a square into r multiplies to all the three terms. A square into r plus a square r into r square, that is nothing but r raised to 3. A square r into r raised to 4 is nothing but r raised to 5 whole square is that. Now we will simplify this. See, in place of a square into r, we want a into b here. So we will write that a square into r as a into ar, so that I can write a into b. B is nothing but a into r. Next, a square into r raised to 3. A square into r raised to 3. In place of that, we want b into c. B is nothing but ar. Let me write that one as a into r. And what are the terms remaining there? One time a is remaining, two times r is remaining. That can be written as a into r square. See, a into a, again it will be a square only. R into r square, again it will be r cube only. We are not adding any extra terms there. A square into r raised to 5. A square into r raised to 5. In place of that, we want c into d. What is c there? C is a into r square. A into r square. Next, a into r raised to 5. One times a we have used and two times r we have used. What are the remaining? One time a, three times r. That means a into r cube whole square, that will be as it is. Now you write a means a, let it be as it is. A into r is b, write b. Here a into r is b, a into r square is c. Next this will be cd whole square. This is the required RHS. With this, problem number 25 in the exercise 9.3 completed. Now we will go to the concept, that is geometric mean. Next problem number 26 onwards, those problems are on the concept of geometric mean. Geometric mean concept. In short form, we used to write ZM, capital G, capital M. So ZM. What is geometric mean? See, there are two numbers, 2 and 8. I want to insert a number between 2 and 8 such that the resulting sequence will be in GP. What is that number? That number is 4. 2 ಮತ್ತೆ 8 ಅಂತ ಎರಡು ನಂಬರ್ಗಳಿದಾವ್ರಿ. ಆ ಎರಡು ನಂಬರ್ಗಳ ಮಧ್ಯೆ ನಾವು ಒಂದು ನಂಬರ್ ಅನ್ನು ಬರೀಬೇಕು. ಆ ನಂಬರ್ ಅನ್ನು ಬರೆದ 2 and 8 are ಪಾಸಿಟಿವ್ ನಂಬರ್ಸ್. ಎರಡು ಪಾಸಿಟಿವ್ ನಂಬರ್ಗಳಿದಾವ್ರಿ. ಆ ಪಾಸಿಟಿವ್ ನಂಬರ್ಗಳ ಮಧ್ಯೆ ನಾನು ಒಂದು ನಂಬರ್ ಅನ್ನು ಬರೀಬೇಕು. ಬರೆದಾದ್ಮೇಲೆ ಏನೊಂದು ಸೀಕ್ವೆನ್ಸ್ ಬರ್ತದಲ್ಲ, ಆ ಸೀಕ್ವೆನ್ಸ್ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರೋಗ್ರೆಷನ್ ಅಲ್ಲಿ ಇರಬೇಕು. ಆತರ ನಾವು ಯಾವ ನಂಬರ್ ಅನ್ನು ಬರೀಬಹುದು? ಇಲ್ಲಿ 4 ಅನ್ನು ಬರೀಬೇಕು. ನೋಡ್ರಿ, 4 ಅನ್ನು ಬರೆದಾದ್ಮೇಲೆ if I take the ratio between first two terms, that is 4/2 is nothing but 2, and ratio between next two terms 8/4, again it is 2 only. So 2, 4, 8 are in geometric progression. Yes, it is correct. Now let me choose another one example. I have 2 and 32. 2 and 32, there are two numbers. Between this 2 and 32 positive numbers, I want to insert a number such that the resulting sequence is in geometric progression. That number will be 8. Now let us check whether it is correct or not. Ratio between first two terms, that is a2/a1, is 8/2. 2 ones are 2 4s are, we are getting 4. Next, suppose we take the ratio between second term and third term, 32/8. 8 ones are 8 fours are. Again you see we are getting the ratio between second term and third term as a 4 again. Means how will you get this middle term? How to insert a number between two given positive numbers so that the resulting sequence becomes a geometric progression. That number will be that number is called as a geometric mean. How will you write it in general? In general, I can let G is the term. J is the term to be inserted between two positive numbers A and B. That means such that the resulting sequence is in geometric progression. That means AGB is in GP. AGB is in GP. If it is in GP, if it is in geometric progression, ratio between first two terms, that is G by A, should be same as ratio between next two terms, that is B by Z. You observe here, if you cross multiply, this becomes Z square is equal to A into B. Then Z is equal to square root of A into B. Here G is called geometric mean of A and B. You see here, coming to the example, 2 and 8 are the two numbers. We are inserting a number between those two. Geometric mean of 2 and 8 we will calculate. What is the geometric mean of 2 and 8? GM of 2 and 8. That is nothing but square root of A into B. A is 2 here, B is 8. So 2 into 8, that is square root of 16. What is square root of 16? 4. So 4 is the geometric mean of 2 and 8. Now coming to this, between 2 and 32, we are inserting a number such that the resulting sequence will be in geometric progression. What is the geometric mean of 2 and 32? You take the geometric mean of 2 and 32, that is nothing but Z is square root of A into B. Square root of A is 2 and B is 32. Square root of 64. Square root of 64 is 8. You see, 2, 8 and 32 are in the geometric progression here. That is about the concept of geometric progression. I will write one more sentence here. If A and B are two given positive numbers, A and B are two given positive numbers, then their geometric mean is, ZM is equal to square root of A into B. That is about it. Okay, fine. Next thing is that up to here there were only two terms. We learned how to insert a number between them. ಇಲ್ಲಿಯವರೆಗೂ ಎರಡು ನಂಬರ್ಗಳು ಇದ್ದವು ರೀ. ಆ ಎರಡು ನಂಬರ್ಗಳ ಮಧ್ಯೆ ಒಂದು ನಂಬರನ್ನ ಹೆಂಗೆ ಇನ್ಸರ್ಟ್ ಮಾಡೋದು ಅಂತ ಕಲಿತೀವಿ. Now suppose between two given positive numbers, if they want to insert 2 numbers, 3 numbers, 4 numbers, 5 numbers, then what we will do? Then we will follow the method. Let us take the heading like to insert n numbers between positive terms A and B. A ಮತ್ತೆ B ಗಳ ಮಧ್ಯೆ n ಪದಗಳನ್ನು ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡಾತೀವ್ರಿ, such that sequence will be in GP. sequence will be in a geometric progression. Okay, very simple steps to be followed here. What are the terms to be inserted? N terms are to be inserted, you know. Let me take all those N inserted terms. Let Z1, Z2, Z3, so on up to Gn are the terms to be inserted between A and B. A ಮತ್ತೆ B ಗಳ ಮಧ್ಯೆ G1, G2, G3 up to Gn ಅನ್ನು ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ವಿ ಅಂದ್ರೆ the resulting sequence will be what happens to the resulting sequence? A will be the first term, that is fixed, and now we are inserting Z1, Z2, Z3, so on up to Gn, and this last term will be B. Fine. If you compare this sequence with the general geometric progression, what happens? This will be the first term. And what about the second term? Second term, G1 is nothing but A into R. What about the G2? G2 is a third term, that is nothing but A into R square in the geometric progression. G3 is the third inserted term, but it is fourth term in the geometric progression. G2 is what? G2 is the second inserted term. ನಾವು ಟರ್ಮ್ಗಳನ್ನ ಎ ಮತ್ತು ಬಿ ಗಳ ಮಧ್ಯೆ ಇನ್ಸರ್ಟ್ ಮಾಡತ್ತೀವಲ್ರಿ, ಅದರಲ್ಲಿ ಎರಡನೆಯ ಇನ್ಸರ್ಟೆಡ್ ಟರ್ಮ್ ಅದು. ಆದರೆ ಜಾಮೆಟ್ರಿಕ್ ಪ್ರೋಗ್ರೆಷನ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ಇದು ಮೂರನೆಯ ಪದ. ಓಕೆ, ವಾಟ್ ಅಬೌಟ್ G3? G3 is nothing but A into R cube. So on. What will be Gn? G2 A into R square. G1 is A into R. G3 A into R cube. G3 third term, here same power is there. In the same way, Gn will be A into R to the power n. Then what will be B? B will be next term to this. So A into R to the power of n plus 1 will be the B. Very simple. Now, first inserted term will be what? First inserted term is G1 is equal to AR. And what about the second inserted term? Second inserted term Z2 is equal to A into R square. Next, in the same way, third inserted term, fourth inserted term, all those I can write. Nth inserted term will be An is equal to A into R to the power n. We should not confuse with the terms, general terms of the geometric progression and the terms we are inserting here. Terms inserting A into R to the power of n will be there. In general, nth term will be, that is A into R to the power of n minus 1 will be there. Okay. Suppose they give you two numbers between 2 and 32. Insert 3 numbers between them. 3 ನಂಬರ್ಗಳನ್ನ A ಮತ್ತು B ಗಳ ಮಧ್ಯೆ ಇನ್ಸರ್ಟ್ ಮಾಡ್ರಿ ಅಂತ ಕೊಟ್ಟರೆ ಯಾವ ನಂಬರ್ಗಳನ್ನ ನೀವು ಮಾಡ್ತೀರಿ? Those 3 numbers will be G1, G2, G3. What is G1? G1 is A into R. A will be the first term, it will be given to us directly, and now our task is to find out R. Common ratio we should find out. How will you find the common ratio? Common ratio we will find using the last term. Using nth term, that is nth term, last term. We have here, we have B is the last term, and in geometric progression it is compared with A into R to the power of n plus 1. We need to separate for R here. That's all. Take this A to the left hand side. B by A is equal to R to the power of n plus 1. Now this power we don't want on the right hand side. Let me take it to the left hand side. This becomes B by A whole to the power of 1 by n plus 1, which is equal to R. Common ratio here, common ratio while inserting the terms, R is equal to B by A whole to the power of 1 by n plus 1. This is the formula we need to remember. From here to here you may get confused with this step. That's why I will explain with an example. Suppose I have B is equal to A square. B is equal to A square. If I take the root on both sides, what happens? This becomes root B is equal to A. Root B, how will you write? we will write the root b as b to the power of 1 by 2. Root is nothing but power 1 by 2, which is equal to a. You see here, a square, if it comes to the left hand side, that becomes 1 by, like that. And suppose I have m is equal to n to the power of 3 is there. Now, if I take cube root on both sides, what happens to this? Here it becomes m to the power of 1 by 3 is equal to n. This is what the concept is. In the same way here, n plus 1 is there. Power of r is n plus 1. We have to take n plus 1th root on both sides. ಎರಡು ಕಡೆ ನೀವು n plus 1th root ಅನ್ನು ತಗೋಬೇಕು. ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ n plus 1th root ಮತ್ತೆ n plus 1th ಪವರ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ. ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ n plus 1th ಪವರ್ ಹಾಗೆ ಉಳಿತೈತ್ರಿ. ಓಕೆ, this is how we should insert terms between given two terms a and b, where first term is a and b will be the last term. Now we will take an example, one simple example we will take. We have an example here in the NCERT, example number 17. Insert three numbers between 1 and 256. Example 17. Insert three numbers between 1 and 256, so that the resulting sequence is a GP. So that the resulting sequence is a GP, is a geometric progression. Fine. Insert three numbers. How many numbers we are inserting? That is here, three numbers we are inserting. N is equal to 3. In case of inserting the terms, n is how many terms we are inserting. You have to be careful. Between 1 and 256 means a is equal to 1, b is equal to 256. So that the resulting sequence is in GP. It is in geometric progression. Okay, three terms we are inserting. Let Z1, Z2 and Z3 are the terms to be inserted between 1 and 256. Z1 we know, that is a into r. Z2 we know, that is a into r square. Z3 we know, that is a into r cube. Here a is directly known to us. Now we need to find the r, common ratio. Common ratio r is equal to what is the formula we know? We know the formula as b by a whole to the power of 1 by n plus 1. R is equal to b by a. What is b? That is 256 by 1 whole to the power of 1 by. This n is 3. 3 plus 1. This is nothing but 256 to the power of 1 by 4. Here 256. I can write this one as 4 to the power of 4. 4 to the power of 4. 4 if you multiply 4 times 4 into 4 into 4 into 4, this becomes 256. That can be written as plus or minus 4. Plus or minus 4 whole to the power of 4. Even minus 4 to the power of 4 is also 256 whole to the power of 1 by 4. So this 4 get cancels. We have r as a plus or minus 4. Both the cases we need to consider here. Okay. That is case number 1. Case number 1. When r is equal to plus 4. What are the terms here? When r is equal to plus 4, z1 is equal to a into r. That is, what is a? What is a? A is 1 into r is plus 4. We have z1 is plus 4. And z2 is a into r square. 1 into minus 4 consider plus 4. Plus 4 square means 16 it is. And Z3 is equal to A into R cube. A is 1, 4 to the power of 3. 4 to the power of 3 is 16 into 4 is 64. Therefore, GP is first term will be 1, 4, 16, 64, 256. And now coming to the case number 2, that is when R is equal to minus 4. Case second, when R is equal to minus 4. Now Z1, A into R. A is 1, R is minus 4. This is nothing but minus 4. Z2 is equal to A into R square. 1 into minus 4 square. Minus 4 square is also plus 16. Z3 is A into R cube. 1 into R is minus 4. Whole to the power of 3 is minus 4 into minus 4 into minus 4. Minus is 3 times. That becomes minus 64. Okay, 3 terms we found. Therefore, the ZP is 1, minus 4, 16, minus 64, 256. This is how we should work with the inserting terms. One thing I would like to tell for first year students, simply whatever we do here, you are copying. I think some of you are working well, some of you are not working. So what to do? After each session, I will give you homeworks. Those homeworks you try well. In the next class, I will solve all those. Don't worry. So, for your homework, today you solve problem number 26 in the exercise 9.3 and problem number 27. 26 and 27 I want you to solve. Thank you. Sir, कोया sound